let's take a look at this one. Remember, we're looking at chapter 3 for this, the parallel lines with the transversal cut through. So if you look, first of all, we've got the vertical angles, right? So angle 1 is definitely the same as angle 4. And if we look, angle 1 and angle 4 each have a corresponding angle pair on the other cross. Angle 1 matches with angle 5. And angle 4 matches with angle 8. So all 4 of these are the same as each other. So that's one pair, oh well, more than a pair, one quadruple of angles that all match together. Whatever angle 1 is, the same is true for angle 4, angle 5, and angle 8. So this is 50, this would be 50, this would be 50, and this would be 50. Now let's look at the other 4. Same thing, angle 2 and angle 3, they're vertical angles. And angle 2 and angle 3 each have a corresponding pair on the other cross, 6 and 7. 2 matches with 6, 3 matches with 7. And so we can talk about these 4 angles being all the same too. Now, if you remember, linear pairs add up to 180. So if we know one of these angles, we can actually find all 8. Like if this is angle 2, if this is 30 degrees, automatically you know this is 150. So all these here are 30. And then all the other ones are going to have to be 150. So it's just a matter of identifying which pairs work. And we're going to see that this is going to be really useful today, especially going later. So what are we trying to do today? We're going to be able to show that triangles are similar, and we're going to use 3 postulates. These 3 postulates are kind of like the ones we talked about for congruence, but they're a little bit different because now we're talking about similarity. All right. So we're going to identify what information is given so that we can figure out whether or not we're using angle-angle similarity, side-side-side similarity, or side-angle-side similarity. All right. So let's start out with angle-angle. Now, I don't really like the way the book does this. To me, it's far more intuitive to start out with saying, okay, well, if we knew all 3 angle pairs are this, because every single time we've talked about anything with triangles, especially when we're talking about congruence, there's always 3 things, right? Side, 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 angle, side, angle, side, angle, 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 side, right angle, hypotenuse, leg. There are always 3 things, but here there's only 2? No. When you have a triangle, you want 3 bits of information. So if we're talking about this, basically what we want is all 3 pairs of angles the same. If we've got all 3 pairs of angles the same, then it turns out that you've got similar triangles. The reason I don't like this, which is the way that the book does it, so I want to show it to you, is because, well, here there's only 2 things. Where's that third thing? They just don't talk about it. And the reason that they just jump straight to this, I'll tell you very honestly, the reason that they just jump straight to this is because of that third angles theorem that we talked about way back when, chapter 4. Because if we know that 2 of the 3 angles are the same as each other, that third pair has to be the same, right? If you've got 50 and 80 on two triangles, we ask ourselves, okay, well, these two are the same. What about that third angle? Well, we can just say, okay, well, what do the other ones have to be? Well, the three angles of a triangle add up to 180, which we already know. And so 180 minus 80 minus 50 leaves us with 50, right? Well, if this is 80 and this is 50, well, this one has to be 50 too, right? Again, 180 minus 80 minus 50 leaves us with 50. So if we've got two pairs of angles that are the same, the third pair of angles is also going to be the same. And so this is why if it was me writing a textbook, I wouldn't call this the angle-angle postulate. I'd go angle, 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 because that's the whole pattern, right? The whole pattern is that you've got three pieces of information because they're triangles. Triangles are a lot easier to satisfy when you've got three pieces of information. But here, the reason that they're doing just two, one is because they think that it's simpler to come up with two angles than it is three, which, okay, maybe, but the whole point is, well, why is it only two? Well, it's because the third one, buy two, get one free, right? With triangles. So in the book, they're always going to talk about angle, angle, but it's really important for you to understand that the reason that they talk about two is because you get the third one for free. That's also why in the book they don't call it right angle hypotenuse leg. They don't use all three in the name. They just call it hypotenuse leg because the right angle part is sort of implied. So here the same thing. That third angle pair, which should be there, is implied. And they use the third angle theorem to sort of cheat. Okay? So let's use angle angle to show or show that it doesn't work with similarity. So we want to know, are these two triangles similar and why? Well, first things first, if we remember back from congruence, this setup right here with the bow tie always, 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 always gives us extra information, right? You've got vertical angles, so you know whatever these two angles are, they better be the same. So here we've got one pair of angles that's like written out. These are both 45 degrees. Then you've got another pair of angles. They're not written out, but they are for sure the same because they're vertical angles, right? So are they similar? Yes. By angle, angle, similarity. And just like when we were doing this with congruence, we should write down what the angle pairs are. Angle R is congruent to angle V. And I've got to use the three-letter government name for angle S here because I don't know. If I just say angle S, which of these angles am I talking about? I don't know. So WSR, right? That's the one I'm talking about here, is congruent to, well, W goes with B, R goes with V, right? Angle BSV. So are they similar? Yes. By angle, angle, similarity. So that's this part. And then how do you know? That's this part. Okay? So, always be aware when they ask you a question to directly address what they ask you. All right? Give this one a try yourself. See if you can get it. Okay, let's go through this one as well. So here we're not given direct information, right? We're not told two specific angles. We've got the one angle here. This is 90. This is 90. Well, what about the other two? Well, if this is 39 what does this one have to be? If this is 51, what does this one have to be? So 90, 39, and what? 90, 51, and what? So are they the same? Yeah, all three angle pairs are the same. And how do we know? Well, here they didn't have us label. Sometimes what I'll do is I'll label these myself. And then again, if you're doing this, you can pick two. Angle A is congruent to angle F. Angle B is congruent to angle E, right? Okay, moving forward. What do we have? We have yet another set of triangles. Let's take a look at these and see if we get that they're the same with the angles. So we've got a pair here, this angle L and angle R. That's great. We're off to a good start. Let's do exactly like we did in the last one and figure out what's left over. 180 should be the three angles total. Well, here's 70 and 30. So we subtract those from 180, we get 80. Now, 70 and 85, that's 155. We subtract that from 180, we should get 25, right? Do we have two pairs of angles that are the same? We got angle L and angle R. And that's it. We don't have three pairs of angles that are the same. We don't even have two pairs of angles. We just have one. So are they similar? No. Not enough angle pairs are the same. You know, and however you want to explain that is fine. But here, notice what I had to do. I had to show, hey, look, you match them up, they don't match. Only one pair of angles matches. All right, go ahead and give the next one a try. So same idea. All righty, let's go ahead and look this over. So this is an isosceles triangle. So that kind of makes it easier for us because we know that the two base angles here are the same. So this is 68, this is 68. And if we went through and we did this one, well, what's 180 minus 68 minus 68? This is 136, so 44. Yeah, okay, so here's the thing. Already we can see there's a problem. This is 62 degrees. This is 44 degrees. How can these two triangles be the same? They can't. So are they similar? No. Right? And again, how do we know? Well, look, we wrote out the angles. If you see even one angle that's out of place, that's not right from where it should be, you know that they can't be similar. You know, if we were to actually do this, we got 180 minus 62 is 118, right? So what's 118 divided by 2? 59, right? So these would be 59. So you see that these can't be the same. The angles just don't match. They can't match. All right, let's do a couple more. Here we have the other postulates. So we did angle, angle. Now we're going to talk about side, angle, side similarity and side, side, side similarity. So what you can know about side, angle, side similarity and side, side, side similarity, if you remember this from congruence, before it was the three angle pairs match up or the three side pairs match up or whatever combination, right? So for side, side, side congruence, the three side pairs are the same as each other. They're congruent. For a side angle side, you had the two side pairs were congruent, and then the angle in between those were congruent. Right here, what we have is instead of the side pairs being congruent, they're proportional. So you notice what they wrote here. You make a proportion, or here you make an extended proportion for side, side, side. And I'm going to tell you the great part about this is that it's very simple to figure out, is it going to be one or is it going to be the other? Are you given information about 3 pairs of sides or 2 pairs of sides? Right? Because if you're given information about 3 pairs of sides, you know it's side, side, side. 2 pairs of sides, side angle side. If you've got the angle. If you don't have the angle, then there's nothing you can do anyway. All right, so look here. I've been given information about 3 pairs of sides, so I better be able to write a similarity statement if these are the same, right? So here's the way I go about it. I say, okay, well, 1, 2, 3 pairs of sides, 1, 2, 3 pairs of sides. I know I'm going to be using side, side, side similarity. So now what we need to do is see that the side pairs match up. So I always just go the big one, the medium one, the small one. So 15 over 10, because that's the big side here, that's the big side here. And that has to be equal to 12 over 8. Notice how I'm also making sure to do the same one over the same one. So I'm doing the right side triangle over the left side triangle, and then 9 over 6. I need to make sure that these match. 15 over 10, well, that's 1.5. 12 over 8, also 1.5. 9 divided by 6, also 1.5. Hey, they match. Great. So, are they similar? Yes. And so we're going to write a similarity statement. So, what goes with what? You know, what helps me is to, now that I know that they're similar, put the angle stuff in. So in between the two big ones, in between the big one and the small one, in between the two medium-sized ones, just take some time to mark it up so that you know that you did it right. So triangle UST is similar to, well, I did the one angle first, so W. The 2 angle came second, that's X. The 3 angle came third, that's V. All right? And that's going to make a big difference in how you do this. If you put the work down on the paper, if you show what's going on, you're going to have a much, 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 much easier time of doing this work, because I'll tell you, it's super hard to do in your head. I don't do this in my head. I can't do it in my head because it's a lot, and my brain is tiny. I don't have the wrinkles in there to store the information. It's all smooth. So I write stuff down, and it helps. It makes a big difference for me. All right, your turn. Give this one a try. Make sure you're capable of doing it. Alrighty, so same thing. Write it out. Big over small, right? So do 12 over 9. And then I guess both of these are the same, 8 and 8. So 8 over 6. Well, what is that? 1 1/3. 1 1/3. Yeah, so they match, right? So, and the other pair matches too, but I didn't write it because it's also 8 over 6, right? I don't need to do that a third time. But so now when you're trying to name these, notice that there's like a symmetry here. So, I don't know, I could make it go with F. B, I can make it go with E. Then C, I can make it go with G. Or I could flip E and F or A and B, right? It's okay for them to be backwards. It doesn't change anything because these triangles can be flipped over without changing how they look, right? So are they similar? Yes. How do we know? Well, we did it, right? So we'll call it A, B, C, and that's going to be similar to F, E, G. Triangle F, E, G. Okay? All right. Last couple. So here, notice we don't have um three pairs of sides. These two triangles, first of all, they're nested into each other. Y'all see how you got a small triangle and you got a big triangle? Break them apart. Don't let them sit here. This is confusing the way it's written, right? So draw them out separate. Take the time, draw them out separate because it does make your life easier. I'm going to put that over there. It does make your life easier if you draw them out separately. That's cool. Changes the. Okay, well, anyway. So let's look at what we've got here. First of all, this angle K, right? They have that in common. So here we've already got a side pair, angle pair, right? So since we don't have three pairs of sides, but we do have an angle, we're probably looking side, angle, side similarity, right? So let's call this KPL, the smaller one, and then KMN, the bigger one. KP has a length of 12. KL has a length of 8. But what about KM? KM goes all the way through. So if this is 8 and 2, we have 10 right here, right? KN is 15. So once again, make sure you're putting the big one with the big one and the small one with the small one, right? So 15 over 12 needs to be the same as 10 over 8. And if we do this, we get like 5 over 4. We get 1.25 equals 1.25. So yeah, right? Are they similar? Yes. By side, angle, side. We only have two sides, but we have the angle pair in between. So the similarity statement, let's make sure we do it right. The K's go together there. And then KL went with KM, so just be aware of that. And then KP goes with KN. And there we go. There's our similarity statement right here. Okay. All right. Give this one a try. Okay. Same idea goes here. Break them apart. Get two different triangles so that you have an easier time of seeing what you're doing, right? A, W, L, A, E, C, and then these are right angles, so you can just mark them. And then AW we know is 6, AL we know is 8, AE we know is 6 and 6, which is 12, AC is 8 and 8, which is 16. And if we do the math, right, side, angle, side, so we got, again, just, I like to go big over small because usually that means that my math is easier. But it doesn't matter. If you want to go 6 over 12 equals 8 over 16, you're going to get the same result, right? 12 over 6, you'll get 2. 6 over 12, you would get 1/2. 16 over 8, you get 2. 8 over 16, you would have gotten 1/2. But you'll show that they're the same regardless. As long as you do the consistent work, you'll see that they'll be the same. So we got angle, side here. And again, make sure that what you have matches. So if we're going triangle AWL, we'd better say that it's similar to AEC. And there we go.